Welcome to today's tutorials that is on angle of elevation and depression. When we talk about angle of elevation, the angle of elevation denotes the angle from the horizontal upward to an object. That is, an observer's line of sight will be above the horizontal. Now, we are talking about an observer here, and here is the object. You look from downwards upwards. The angle formed here is what we call along the horizontal, with the horizontal here is what we call the angle of elevation. When we talk about angle of depression, this angle of depression denotes the angle from the horizontal downwards to an object. From the horizontal downwards to an object. That is, an observer's line of sight will be below the horizontal, line. That is, if you have an horizontal line here, then the object is down here. This is the line of sight. Then the angle formed with the horizontal at this point downwards is what we call the angle of depression. It's what we call the angle of depression. You need to know that the angle of elevation and that angle of depression are congruent, meaning that they are equal. The angle of elevation and angle of depression are equal. That is, if we have an angle of depression here and an angle of elevation here, the two angles are equal. The two angles are equal. That is, the angle of depression equal to the angle of elevation. I'm going to demonstrate this by using GeoGebra software as follows. This is the use of GeoGebra on the angle of elevation and that of depression. I shall be moving this point C and the point B so that you see the changes in depression and elevation. As we have discussed from above, when we talk about depression is when you are looking from the top to the bottom to the ground. And when you are looking from down upwards, the angle formed is that angle of elevation. Now, you realize that the angle of depression is always outside the triangle, and the angle of elevation is inside the triangle. It is always outside the triangle, and this one is always inside the triangle. If this is the ground, that's the horizontal ground, this is the altitude, which is the height in this case. We also call it the height, and this is the slant height, the slant range. So if I move this C, that means I change the angle of depression. I'm changing the angle of depression. You see, it is 35, 36. So that means the height also reduces because I'm reducing the height, the altitude. If I increase the height, the altitude, the angle of depression. So you are here, you are looking downwards. This is the angle formed here, is the angle of depression. If you are looking on this other side, then the angle of depression could have been here. Now, you realize that the angle of depression and the angle of elevation, like we discussed, they are equal, 42.85, 42.85. That is, they are congruent, meaning they are equal because these are alternate angles. Alternate angles are equal, or in simple terms, they are congruent. So, you realize one thing which is very important, that if I move B towards the 90, towards the height, towards the altitude, the angle increases as you move towards the 90 degrees, that is towards the altitude. But as you move away from the altitude, the angle reduces. Like if I move this B, the angle is increased to 47, you can see 49 there, you can see 52, you can see 58, you can see 69, 70, you can see that is 77. And the horizontal distance that's on the ground also reduces. Horizontal ground to the ground reduces, so it increases towards the 90. And when you move away from the 90, the angle reduces. The angle reduces as you move the words away from the 90. When you move away from the 90, the angle reduces. So, in situations where you are told that an observer may be from down or even from up, if he's observing from up a cliff, then downwards, the angle is that of depression that will be equal to the angle of elevation. So, if you are told that you observed two objects, one at an angle of 30 degrees and another one at an angle of 40 degrees. So that means the 30 degrees will be outside and the 40 degrees will be inside, because you are moving towards the 90. So you realize 40 degrees can be here and then 30 degrees becomes now outside here. But that is where most of students go wrong. Like if it's 40 degrees and 30 degrees, they now draw like here, they say this is now the 30, and then the outside they draw and they say that it's 40, because they think that is the correct thing. But that's wrong. That is where you go wrong and you answer your question wrongly. So from this demonstration of GeoGebra, you can see that the angle increases as you move towards the 90 degrees and also reduces as you move away from the 90 degrees. And I've said that if you look from above, this is the angle of depression and this is the angle of elevation, they are always equal. They are always equal. They are always equal. You realize that as you move this distance, as the distance decreases, the shorter the distance, the shorter the angle of depression. And if the altitude is very high, as you increase, the higher or the bigger the angle of depression that you are. This one is the line of sight. You are looking from this point, so the angle of depression increases. So I hope that this is helpful to you now, for you to be able to answer the questions as we are going to discuss in the examples that follow. An artificial Earth satellite is measured from two Earth stations. Situated on the same side of the satellite are found to be 30 degrees and 60 degrees. The two Earth stations and the satellite are in the same vertical plane. If the distance between the Earth stations is 4,000 kilometers, find the distance between the satellite and the Earth to the nearest whole number. Now, the first thing you do is you sketch the figure. You sketch the positions. So you are told that the angle of elevation of an artificial Earth station is measured from two Earth stations. So you take your station 1 to be somewhere. First of all, you have an horizontal line, like we discussed about an horizontal line. So you draw an horizontal line here because you're talking about elevation, meaning you're looking from the bottom upwards. So you draw an horizontal line, and then you name one station. Remember I said the angle increases to the 90. If I put my 90 here, assuming my satellite is at this point A, and this is the ground, and this is the Earth. Here, the horizontal line is the Earth, and the satellite is here. So you have your station 1. Station 1, we have been told that situated on the same side of the satellite are found to be 30 degrees and 60 degrees. So that means if you have one station 1 and station 2, the 60 degrees should be towards the 90 here. So it should be the one inside, the 60 degrees and the 30 degrees as you move away, like we described. The angle reduces, and as we move towards the 90, the angle increases. So the 60 will be here and the 30 will be here. That is, if you look from here upwards, this is my angle of elevation 30 and this is my angle of elevation 60. So after drawing, sketching this, remember we have been told that the distance in between, that is C to D, between the two, because we are told between the two stations is 4,000 kilometers. That is, if the distance between the Earth stations, between station C and station D, is 4,000 kilometers, we find the distance between the satellite and the Earth. That means we find the vertical distance between the satellite and the Earth, AB. This is the distance we are asked. We have this distance. So what we do, we know that if we learned, you've ever heard about tan theta, cos theta, and sine of theta, you understand that you understand what we call SOHCAHTOA. So you understand what we call You understand what we call SOHCAHTOA. SOHCAHTOA is an abbreviation. SOHCAHTOA is an abbreviation whereby here we say sine of theta equals to opposite. O stands for opposite, or over hypotenuse. H stands for hypotenuse. And then we say cos of theta equals to adjacent or over hypotenuse. We also say that tan of theta equals to opposite or over adjacent. A stands for adjacent. So here I've said that sine theta, sine of angle of theta equals to opposite. We call it, say, opposite all over hypotenuse. We also say that cos of theta, we say that cos of an angle theta is not necessarily to be theta, it can be x angle, x or whichever angle. And remember, this one deals with only right angled triangle. So cos of theta, only right angled triangle. So don't use for another triangle, is right angled triangle. Cos of theta will be adjacent over hypotenuse, equals to adjacent all over hypotenuse. Good. And then you continue, tan of theta, tan theta equals to opposite side or the adjacent side. Opposite side or adjacent side. That is the tangent of theta. Now, when we talk about, like, if I'm dealing with 60 degrees, the opposite side of 60 degrees is this side AB. The adjacent side, meaning the side apart from this one is the longer side. The longer side here is the hypotenuse. This is the hypotenuse. And for this other triangle, this is the hypotenuse. So if we are talking about this 60 degrees, the adjacent is BC. Adjacent to 60 degrees is BC, and the opposite to 60 degrees is AB, and the hypotenuse to 60 degrees is AC. If you had an angle like here, let's say you have an angle here, the angle, assume the angle is here. So if we have an angle here, theta, an angle theta here. Now, this angle theta, opposite to this angle theta will be BD. Adjacent to this angle theta will be AD. So an angle theta, the line that is adjacent to angle theta here is AD. And the line that is opposite to this, the side that is opposite to this angle theta here, it is BC. So, and the hypotenuse obviously is AD. So that is how you identify the, assuming that you had this side hypotenuse. You had the hypotenuse. If you had the hypotenuse, now you write yourself that the sides that you have, for instance, if I'm talking about this 60, I'm looking for this side, and I have this side. You know, remember, I'm dealing with the adjacent. This is what I'm working with. I'm looking for the adjacent and the opposite to this angle 60. So that means the abbreviation that deals with the opposite and the adjacent, remember, this will be the adjacent and this will be the opposite. One that deals with the opposite and adjacent will be this one. If I'm talking about adjacent and hypotenuse, it will be the cosine. If I'm talking about an adjacent here and hypotenuse, assuming that I had this side and this side, I can easily find the angle theta. If you have this side and this side, you can easily find the angle theta. So that is how you apply SOHCAHTOA. It's good to understand how you apply SOHCAHTOA. Now, in this case, I've said that tan theta equals to opposite all over adjacent. So from there, I realize that tan of 60 degrees, the tangent of 60 degrees, equals to side of AB, becomes the opposite to this 60 degrees. AB outside BC, outside BC. So I'll say that now to get AB, because I'm interested with this AB, I don't have AB. I'm interested with AB. To get AB equals to tan of 60 times BC. Tan of 60 times BC. Tan of 60 times BC. Tan of 60, you press your calculator, you press tan 60. Or use your mathematical table, you'll find the tan of 60 to be 1.7321. So that means AB is equals to 1.7321 times BC. That we get as our equation 1. And then we look for the tan of this 30 degrees. Tan of this 30 degrees, because we are interested with this common side AB. So tan of 30 degrees equals to, remember we are talking about AB opposite, because tangent is opposite side of adjacent. The opposite is AB, and the adjacent for 30 degrees will be from B to D. So it will be tan of 30 degrees equals to AB over BC plus 4,000. Remember, from C to D is 4,000. So it will be BC plus 4,000. That is AB tan 30 degrees equals to opposite, which is AB, all over adjacent, which is BC plus 4,000 degrees that we already have here. It is AB all over BC plus 4,000 kilometers. Now we have 4,000 kilometers we are given as our CD. Now, and tan 30 equals to that. So from here, that means we make also AB the subject. Then that means our AB will be equal to tan of 30 times BC plus 4,000. That's tan of 30 into brackets BC plus 4,000. Plus 4,000. So the tan of that is 0.57774. 0.5774. That is tan of 30. So that means our AB is equals to 0.774 into brackets BC plus 4,000. This gives you open the bracket, it will be, this will give you, this times this one gives you 2,096, then plus 0.774 BC. That becomes our equation 2. Now, because this is AB is this one and AB is also this one, we equate this and this one. We shall equate the two. We equate the two equations. After equating the two equations, we will find that this 1.7321 BC equals to 2.2309. That's 2,309.6 plus 0.774 BC. Now, like terms together, this has a BC and this has a BC. So it will be 1.7321 BC minus 1.7 this minus 0.577 BC will be equal to, this remains on the right hand side, will be equal to 2309.6. So when you minus these two, you get 1.1547 BC. This equals to 2309.6. So that means if I divide both sides by 1.1547, if I divide both sides, then I remain with BC here, then BC will be equal to this one divided by this. That is 2309.6 divided by 1.1547. This gives you 2000.1732, which is approximately equal to 2,000 kilometers to the whole number. To the next whole number, it is 2,000 kilometers. Then, that means we understand that our AB was distance of the satellite from the Earth. So that is what we were asked, the distance of the satellite to the Earth, from the satellite to the Earth. That was the distance AB, which is, to get our AB, remember this is my BC. Now we need AB. AB, you can use this one. You can use this one because this one gives you AB. AB is equals to this. Or you can use this one, AB. You can also use this one. This first equation or the second equation, you get AB. So if I use the first equation, it will be 1.7321 times 2,000.1732 0.1732. If I multiply the 2, I will get to the next whole number. It will be 3465 kilometers. 3465 kilometers. You just press your calculator to get 3465 kilometers. To get 3465 kilometers. So that is how we were supposed to find the distance of the satellite to the ground. That's how we were supposed to find it. Let's look at our example number 2. From the top of a tower of height 60 meters, the angle of depression of the top and the bottom of a building are observed to be 30 degrees and 60 degrees respectively. So 30 degrees is the angle of depression of the top and the bottom of a building. So the top of a building, from the tower to the top of a building, the angle of depression is 30 degrees. And from the top of the building to the ground, that is from the top of the tower to the ground of the building, the angle of depression is 60 degrees respectively. Find the height of the building. So the first thing you do is to sketch. You sketch first. So that means if this is the building from here up to here, the building is from here up to here, EC, this is the building. If you have the building here, and this is the tower, remember the tower is from the floor up to the tower, the top of the tower is at this point. Now when you look from the top of the tower to the top of the building, the angle of depression, remember you are looking from above here. So this angle of depression of the what? Of the top of the tower to the top of the building is this angle of depression is 30 degrees. Then this angle, remember we said that angle of depression and angle of elevation, they are adjacent angle, or we say they are congruent angles, meaning they are equal. So the angle of this depression, and the angle, it becomes now the angle of elevation. The angle of depression becomes the angle of elevation. So this 30 degrees equals to the 30 degrees here. And then that is from the top of the tower to the top of the building here. And then now you also need to observe from the top of the tower to the bottom of the building here an angle of 60 degrees. Now, from this is the tower. Remember the horizontal line of the tower is here. So you must use the horizontal line, the angle it makes with the horizontal line of the tower. From the horizontal line, you measure 60 degrees. If you are doing by scale drawing, you have to measure those angles correctly. You measure those angles correctly if you are doing by scale drawing. All this we are doing with calculations, you can do them with scale drawing. While in Form 1, you need to do them with scale drawing. But when you come to Form 2, you deal with trigonometry where we use SOHCAHTOA. That is when you do calculations. But while in Form 1, you do them using scale drawing. Now you measure the angle correctly. You measure this angle 60 degrees. 60 degrees now will be from this horizontal line to this point. You measure 60 degrees. Then you have your line to the bottom of the building. Now this 60 degrees is the same as this angle 60 degrees. It's the same as the 60 degrees. Remember we said the angle of depression is always outside the triangle. So 60 degrees, it's outside this triangle that I'm dealing with. So this is 60 degrees, which is the same as the angle of depression here, becomes equal to the angle of elevation at this point. So after sketching this one, we are required to find the height of the building. We are required to find BD. Remember, we are told that the height of the tower, that is from here, the bottom up to AD, is 60 meters. So we need to find B to D. So what we do, we have to let AD and BD to give them some letters. Like, that's the distance required is BD. Now, we let AB, if I let AB to be equal to X, and BC, I also let BC to be Y. Remember this BC, Y is equal to DE, because it is the horizontal, they are equal. So this is BC equals to DE equals to Y, if we let them to be Y. Then that means I'll say, if I use this 60, I'll say I've let this one to be X. That means BD equals to, if I let AB to be X, then BD equals to 60 minus X. 60 minus X, that gives you BD. Now, tan of this 60, TOA, we said it's opposite over adjacent. So the adjacent is DE to 60 and the opposite is AD. So tan of 60 degrees equals to the whole line opposite, which is 60, divided by DE, which is Y. So tan of 60 equals to 60 all over Y. And therefore from here we can substitute to get Y equals to 60 over tan of 60. Y equals to 60 all over tan of 60. Y equals to 60 over tan of 60. Now you just press 60 divided by tan of 60 using your calculator. You find 34.64 kilometers. You find 34.64 kilometers. Remember, in Form 1, you just do all of this by scale drawing. Because you are asked, you let a scale like 1 centimeter to represent 10 meters. That means this distance will be 60 divided by 10, 6 centimeters. You want to measure 60 centimeters. Then after measuring 60 centimeters, remember you drew the horizontal there. Then you measured an angle of 30 to this point. You drew a line. And then you measured another angle here, 60. You drew a line. And then from there, you had to find, you are interested with this. Now, after measuring all that, you've measured 60, which is equal, you draw a line. Then there is an horizontal from this point. You want to draw a line straight, it means this. Why it means that? That is where 60 also is formed. Just they meet, that's why 60 is formed. And then you also drew this line after measuring the angle, that. Then you are supposed to now draw some line again from you also draw a line where this one meets here. You draw a vertical line, it will meet this line here, it will meet this other line. Where it meets, you join. So that means you are able to measure now this in centimeters. After measuring this in centimeters, you multiply by 10. So that is how you do by scale drawing. But by calculation, you now easily find y equals to 60 divided by tan of 60, which is 34.64 kilometers. So the distance from here to here is 34.64 kilometers. It will assist us because now we talk about tan of this 30 equals to opposite, which is now AB, which is x. Tan of 30 equals to x. AB, we write it to be x. Tan of that equals to x divided by the adjacent. In this case, we have calculated to be 34.64. So that means our x equals to 34.64 times tan of 30 times tan of 30, which gives you 19.999, which is approximately equal to 20 kilometers. So if we find our x from here to be 20 kilometers, that means we can easily find BD. B to D, it is now the whole line, which is 60 minus this one, which is 20, you get it's 40 kilometers. You get this 40 kilometers. That's building of the height, height of the building. Height of the building, not building of the height. This height of the building is equal to BD, which is equal to 60 minus 20, which is equal to 40 kilometers. That is how we find the height of the building. Now, our example number 3, from the top of a cliff 200 meter high, the angle of depression of two places A and B on the ground and on opposite sides of the cliff are 60 degrees and 30 degrees. On opposite sides of the cliff, remember the cliff is 200 meter high. The angle of depression from the cliff, you are at from the top, looking downwards. The angle of depression of places A, we have two places down on the cliff when you look from up, on the ground and are on opposite sides of the cliff are 60 and 30 degrees. Find the distance between A and B. Now what we do, we sketch first. Now if you sketch, remember, if you take this to be the top of the cliff, and this is the cliff here, because we are told there is a cliff TO, and then at the top of the cliff you have to draw an horizontal line, so that if you are measuring, you are doing by scale drawing, you measure the angles correctly. So we have from the top of the cliff, there are two opposite sides of the cliff. So you watch from the top, we have a side B. If I measure 30 degrees to a side B, 30 degrees from here, you measure this angle from here. If you are using scale drawing, you measure from here to here, 30 degrees, you put a line up to a point there, which is our B. And then we also have from this other side, you are looking at the bottom from this other side, you measure this 60 degrees, and then you draw a line. That's our point A. And then you join the two points A and B. Remember, the cliff is 200 meter high. From here to here is 200 meter high. So if you are using scale drawing, you draw this line. After drawing this line, you draw a straight line. You remember, you have a line here, then you measure an angle 30 degrees, you draw a straight line. You measure an angle after drawing this line, which is 200 meter. So 200 meter, you can use a scale like 1 centimeter to represent 1 centimeter to represent, if we talk about 100, it will be 2, that is very small, to represent 50, that means it will be 4 centimeter. So you can measure 50 or use 25, whichever is appropriate, it will give you. Like even if I use 50, it will give me. So if I divide by 50, I shall have 4 centimeter. So I measure 4 centimeter up to here. Then I have, remember I measured 30, I draw this line. I measure 60, I draw another line. After drawing this line, I measured here 5 centimeter. I remember I measured here 5 centimeter because 4 centimeter, 4 centimeter. Now, and I've drawn this, and I've drawn at the bottom here where I have 4 centimeter, I draw a straight line and horizontal line. Where they meet, this angle, if you measure it, it will give you 60, and this angle gives you 30. So you have done it by scale drawing. Then from there, find the distance between A and B. You just measure A to B, because you have drawn an horizontal line. It meets this line and meets this line. You just indicate A and B. You measure A to B. You find the centimeters times 50 to get it in meters. Then you are done. That's by scale drawing. By scale drawing, it is so easy. Then now by calculation, we continue. Now after doing this, we are asked this distance. So I can let A to O to be X and O to B to be Y. So that if I deal with the opposite, remember I'm looking for the adjacent. I'm looking for this adjacent and I'm looking for this adjacent. So I'll deal with this is 90 and this is 90. So I'm dealing with the opposite and the adjacent to this angle. So I'll use still tan. I'll still use tan because the distance I'm needed is AB, which is X plus Y. X plus this Y. So I have to say tan of 60 degrees, tan of this 60 degrees equals to opposite, which is 200 over X adjacent. So my X equals to 200 over tan 60, which is 115.47 meters. Then I also deal with tan 30 the same. Tan of that equals to 200. Tan of this 30 equals to opposite, which is 200 over the adjacent, which is Y. Meaning that my Y equals to 200 over tan of 30. Y equals to 200 divided by tan of 30. Y equals to 200 over tan of 30. Y equals to 200 over tan of 30, which is 346.41. Then if I get this and this, I add the two to get the distance. AB is this 115.47 plus 345.41 meters, which gives you 461.88 meters. So that is the distance between A and B. So if you use the scale drawing and done it correctly, the answer should be plus or minus around 1. So if you got 460 or 462 or 461 accurately, point something, still that is accurate. So the answer should lie in between there if you scale drawing, not too far from this answer, not too far from this answer. So I want to say thank you for listening to my tutorial, and remember to subscribe for me. I'm Mwalimu Ogeke. Thank you.